is lesson 3.3 and 3.4, systems of inequalities and linear programming. Some quick vocab. Systems of inequalities are more than one inequality, and a solution to the system is the intersection of the two shaded regions of the graphs. So let's go ahead and do an example. What is the solution to the systems of inequalities? So first we have our first equation here, and this is written in standard form. Remember, standard form is helpful to find intercepts. In order to find my x-intercept, I will make y 0, and so this tells me that x equals -2. And in order to find my y-intercept, I make x 0, so I have -y equals -4, so y equals 4. From there I can plot those two points. X is -2, y is positive 1, 2, 3, 4. I have a solid, that's a horrible thought, I have a solid line because it is greater than or equal to. And then when I shade in, I'm going to shade above that line because it's greater than. My second line is in y equals mx plus b form, so I will go ahead and start. Let me get my pencil here. In my second equation, my b or my y-intercept is 2. My slope or my rise over run is -1/2. So I'll start at 1, 2, and then I will go down 1 and right 2. Down 1 and right 2. This line will be a dashed line. And then it says greater than, so I will shade above that line. Now, the solution to this system is where both of these lines intersect. Or not where the lines intersect, sorry, where the shading intersects. So my answer will be in this top area here, where my lines intersected. That means any one of those points that I pick within that shaded region could be plugged into both equations and make both equations true. And here we have another system. What is the solution to the system of equalities? Y is less than 3 and y is greater than the absolute value of -1. So let's start with y is 3. We'll go to the y-axis at the point 3. Now remember, what this means is it's telling us y is always 3. If x is 3, y is 3. If x is 5, y is 3. If x is -2, y is 3. So we're going to get a horizontal line through our axis. Then we need to do our shading less than 3. Those will be numbers like 2 and 1 and 0. So all of the numbers below this line will be shaded in. Next, we'll move on to our absolute value graph. -1 on the inside will move our graph 1 to the right. So our vertex starts at 0, 0, but we will move 1 to the right. Our slope is 1, so we'll go up 1 and right 1, up 1 and right 1, and then mirror that up and left 1, up 1, left 1. It's greater than, so we will have a dotted line. Or a dashed line if you prefer. And it says greater than, so we will shade above or inside. Now remember, our solution to the equation is where both of those shadings intersect. So that would be this lovely little beautiful, spectacular, wonderful triangle here. So some quick vocabulary. Linear programming is just graphing to determine the maximum or minimum value. A feasible region is the intersection of all the shaded regions. An objective function is an equation that you're trying to minimize or maximize. And the vertices of a feasible region are the points that will give us the minimum or maximum. Let's look at an example. What points in the feasible region minimize and maximize p for the objective function p equals 2x plus y? So we're looking for an x and a y that minimize and maximize those values. It'll be two different values. So first we'll go ahead and graph our first equation. This is set up perfectly for our intercepts. This is in standard form. So if I want to graph my intercepts, I'll make y 0. Oh, x equals 4. Then I'll make x 0, so 2y equals 4. That means y equals 2. I'll graph those, 4 on the x-axis, 2 on the y-axis. It's going to be a solid line because it is or equal to. And let me make sure it goes through those points. This is why sometimes it's easier just for me to draw it, even though it's not nice. And then it says less than, so we will shade below that line. Our next one is x minus y is less than 2. So if we want to find our x, we make y 0, x equals 2. And if we want to find our y, we make x 0, negative y equals 2. So y equals negative 2. We'll plot those 2 points at 2 and negative 2 at y. And then we'll draw our line through. Our next equation says, we need to do our shading now. So when we go through and do our shading, it says less than. So we need to remember before we can do that when we're doing our shading, we have to have our y value by itself in order to know where we're going to shade. Sometimes it's too difficult, so I'm going to go ahead and pick a point and plug it in and see which way I need to shade. Is 0, 0 part of my solution? So is 0 minus 0, 0 minus 0, less than or equal to 2? Is 0 less than or equal to 2? Yes, it is. So that means 0, 0 needs to be a part of my solution. So that means for this line, I should shade above it. Next, I'm going to graph my next equation. X is greater than 0. So that means that x, no matter what value for y, at 0 or at 3 or at negative 5, it is always going to be 0. So that would be on my vertical line going up and down through here. And it says it's greater than that, so I will shade towards the greater numbers on the right. And then my last and final equation is y is greater than 0, which again, y is greater than is going to be this horizontal line here across my y-axis. And then when I shade the greater than region, it will be above that line. Now, our solution set is going to be, or in this case, we call this our feasible region, the spot where these 4 lines, or these 4 shaded regions all intersect. And that happens to be, trying to do this with a very, very dark color, and it's not showing up as much as I would like it to. It's going to be this region here. Next, we need to look and locate our 4 vertices. We have one here at 0, 0. We have one at 1, 2, 0, 2. We have one at 1, 2, 0. And we have one at 1, 2, 3, 1/2. Now with those points, in order to find our minimizing and maximizing points, we have to plug them in. So 2 times 0 plus 0 equals 0. And again, we're plugging it into our objective function up here. 2 times 0 plus 2 equals 2. 2 times 2 plus 0 equals 4. And 2 times 3 plus 1/2 equals 6.5. So when we calculate what our minimum and maximums are, the smallest number is 0. So 0, 0 will get us our minimum. And the largest number is 6.5. So 3 and 1/2 will get us our maximum. What is Bruce Lee's favorite drink? Water!